We're going to go back, we're going to look at some basic object stuff, try to make sure we can solidify our understanding of what objects are and what it means to create an object. First thing I'm going to do today is create a class for a bank account. It's going to have 3 things in it, and they're all going to be public, and then we're going to work our way forwards from there. So I'm going to switch over to project mode here. I'm going to create a second file called bankaccount.java. Pay attention to the capitalization. Public class bank account. And in here, I'm going to give my bank account an account number, a password, and a balance. So I have an empty main and I have this bank account object here. When I had people start to overload the constructor, people were duplicating these things, whether they were private or public. They were like copy pasting them, where they were writing multiple gets or multiple sets or whatever. Everything I have here, whatever shows up at this top level that's not listed as a method, those are the things that are created every time I create a bank account. So this is the description of what a bank account holds. Every time I create a new bank account object, it's going to create one int, one string, one int, an account number, a password, and a balance. If I were to write public int account number 2 or something like that, then every bank account object would have an account number, an account number 2, a password, and a balance. When I go to my main and I write bank account, call it account 1 equals new bank account, parentheses, run that, make sure that works. What's actually happening here? Java is going to create a new bank account object for me. We can treat the thing like a box with stuff inside of it. For my account 1 variable here, and inside of that, I'm going to have an account number, I'm going to have a password, I'm going to have a balance. Now when I come in here and I say account 1 dot account number, I can set that to something like 2, 3, 4, 5, 6. That dot means I go inside of the account 1 box and I set that thing. So this will now be 2, 3, 4, 5, 6 after line 4 runs. Now if I want to set the password, same kind of thing, account 1 dot password, meaning the password of account 1, and I'll set that equal to dragon because, fun fact, it's one of the most common passwords ever. So after that runs, I'll have password equals dragon. And if I change account 1 dot balance, set that to 50, that's going to set this one down here, this balance, to 50. Now I can create a second one of these objects. Bank account account 2 equals new bank account. When I write that, it's going to create a box for that one as well. So we'll have another box called account 2 or act 2. And that will have an account number, that will have a password, and that will have a balance. These are separate from account 1's account number, password, and balance. Different objects have different things inside of them. They're different variables. I can set account 2 dot account number equal to 33333. That's going to change this one over here, account number, to be 33333. It's not going to modify this. And I can do the same thing for a password, account 2 dot password equals, I'll change this to password 123, another very common password, don't use these. So now this one's password is going to be the string password 123. And then I'll initialize this guy's balance to 0. So now I have balance of 0. These are 2 separate things. They're 2 separate entities. Changing the account number of one doesn't change the account number of another. What I want to do now is change this. Instead of doing it this way, I want to change this so that I can put these things inside the parentheses. So I can say new bank account 2, 3, 4, 5, 6, comma, dragon, comma, 50. And I'm breaking this across multiple lines, but you don't have to. So if I want this to work, and the same thing down here, 33333, password 123, and I'll have 0. I want both of these to work now, but they won't because it's looking for a constructor. It takes 3 arguments, but I don't have any. So I go back into my bank account. They don't need to be private. Private or public doesn't matter whether I write a constructor or not. Realistically, we would want these to be private, but they don't have to be here. So if I want this to work, I'm going to write a constructor. It's going to be a public constructor. So I start with public, bank account, and then I put those 3 things in there. So I have my int, init, account number, string, init, password, and then I will have an int for the initial balance. Now we're inside the braces here. This whole thing can be one line in your code. I'm going to write this dot account number equals init account number, this dot password equals init password, and this dot balance equals init balance. Now I have code that can construct these bank account objects for me. So if I erase what's up here right now, when I first say on line 3 here, bank account act 1 equals new bank account, just that I'm making a new bank account is going to create something like this. It's going to create this box. It's going to have these 3 things in it. We're going to enter our constructor. Inside of the constructor, we take those 3 things that were passed in, as well as the this variable. So right now, inside of this constructor call, we have init account number set to 2, 3, 4, 5, 6. We have a init password set to dragon, and we have a init balance set to 50. But the last thing we also have is this, which is set to account 1. It's another argument that just happens implicitly. You don't have to spell it out yourself. So this is referring to account 1. So now when I do this dot account number equals init account number, it's like I did in the main where I said account 1 dot account number equals 2, 3, 4, 5, 6, because that's what all those variables are now. This is account 1 and init account number is 2, 3, 4, 5, 6. So we fill that in. 2, 3, 4, 5, 6. Now for the password, I look at init password. Init password over here was passed in as dragon, so I set this dot password, this being account 1 dot password equal to that string dragon. Then we come over to balance. Init balance was passed in as 50, so that's what that variable is set to. Now that's what argument is set to. And I do this dot balance equals init balance. Again, this is still referring to account 1, so this dot balance equals 50. And I get the same result as I did when I was writing it out all in my main. I can just delegate that work somewhere else now. Then when I create account 2, I follow those same steps. I create that box for account 2 here. That's going to have my account number, it's going to have my password, it's going to have my balance. So we're running this code again with different arguments. Init account number is going to be just 33333. Init password is going to be password 123, and init balance is going to be 0. And what will this be now? The variable this, it's going to be account 2, because that's what we're constructing. That's the thing that's being used here. That's the thing that we are operating on, account 2. So now this refers to account 2. So when I do this dot account number, it's account 2 dot account number. I set that equal to init account number, which we just said was all 3s. So this dot account number equals 33333. This dot password equals init password, which we just saw was password 123. And this dot balance is going to be set to 0. And now we have these two objects next to each other. What I'd like to be able to do is construct an account without specifying an initial balance. So create a new bank account with this account number and this password. If I leave out the balance, I want to assume the balance is 0. For this to work, I'm going to overload the bank account constructor to just take 2 arguments. So I'll have a second one, public bank account. It's going to take init account number and init password. So this dot account number is going to equal the initial account number. And this dot password is going to equal the initial password. The last thing I'm going to set as a balance. Now I have a constructor that also works with 2 arguments. Notice that when I wrote this second constructor, I didn't duplicate anything up here. I don't need to write a second one of those. These aren't specific to the constructor. These are the things that are created every time I create an object. Every time I create a bank account, it's going to create one of each of those things. Whether I have 1 constructor, whether I have 10 constructors. That's what goes inside the box. If I look back at my main.java, I have these 2 things, account 1 and account 2. If I print out account 1 dot account number, what do I expect this to print? 2, 3, 4, 5, 6. If I change that to be account 2 dot account number, what do I expect this to print now? All 3s, right. If I do account 1 dot account number equals 0, now what do I expect this to print? Still 3s, because we're not changing that. So when I do account 1 dot account number equals 0, I'm changing what's over here in this account 1 variable in this object. So now that account number is 0, but the other one hasn't been changed. If I do account 1 dot balance plus equals 100, and I print out account 1 dot balance, what should this print now? 150, right. So what if I were to do account 2 dot balance equals account 1 dot balance, and then account 2 dot balance plus equals 200. Now what will this print? Prints 50, right, because I'm printing account 1 dot balance. All right, what about this one? So we got dragon 1, 2, 3, 4. So we look at account 1 password, which is dragon right here. In that box, we add 1, 2, 3, 4 to it, and we store it in this box. So then we get dragon 1, 2, 3, 4 as our result. So these things up here, this list, the public int account, public string password, and the public int balance, these 3 things are called instance variables. So here we have the whole class definition. Every time we create an object of that class, we call it an instance of the class. We would say account 1 is an instance of the bank account class. We would say account 2 is an instance of the bank account class. And each of these are the instance variables. So each time we create an instance, we get one of each of these. Someone asked in the other class, they wanted to see what it would look like to read like the password in from the user and put that into the bank account. So using a scanner instead of doing it this way. So all I would do there, if I wanted to ask the user for a password there, I would do import java.util.scanner. I'll create my scanner object. I could prompt the user saying, enter a password. And then read it in, so string password equals keyboard.next. And then instead of putting in dragon here, I just put that password in. So run this now, make sure I get the right thing, enter password, and I can print that out just to verify that it got set. If I go back here, let me revert this to the version with the 2 of them. Whenever we call any function or any method that's overloaded, the compiler has to figure out which one you're trying to call. Here I have new bank account with an int, a string, and an int. Here I have new bank account with an int and a string. So let's take the first case, int, string, int. Everything that fits that name is considered a candidate. So we have bank account here, we have bank account here. Both of these are potentially what we're trying to call. To figure out which one we're actually calling, we need to figure out which one we can call, or which one is the best fit if either one could be called. In here, I have an int account number, a string password, and an init balance, or init and int balance. So that's int, string, int. Down here, I just have int and string. So now my 2 candidates are bank account int string int and bank account int string. If I look back here, I'm passing it int string int. So only one of those is going to work. If I tried to call this one down here with the int string int, that third one would just have to get dropped. And that is kind of obviously not what we would want. So it's going to select this one as the best match, the one that takes 3 arguments. And that's the one will actually be called. Down here, the opposite thing kind of happens. We look at both of them. They're both candidates. They can both be potentially what we're trying to call, because we could be trying to call this one. They both have the name bank account. Could be trying to call that one. But I've only supplied 2 arguments. So I can't call this one because I haven't given anything for what a net balance should be. The next thing I want to talk about is something called an enum. An enum is kind of a way to define your own values. So it'll have a type associated with it, but it also has its own values. So let me give you an example. If we were writing something that dealt with a calendar-like thing where we had the days of the week, we might have a numeric representation of which day we're looking at as either 0 through 6 or 1 through 7, depending on how we want to model it, where 0 is Sunday, 1 is Monday, 2 is Tuesday. If I just had a function that worked like this, it kind of leaves itself open to errors. So let's say I wrote something like this, public static void, I'll just call it func, and then I will take the day of the week here, and I will say if the day of the week equals 0, or day of the week equals 6, and I can write a comment saying Sunday or Saturday, I'll print out that it's the weekend. Otherwise, I will print out go to work. Now down here in my main, if I call this function with 0, that should print out it's the weekend. If I call it with a 2, I should print go to work. So I get it's the weekend, go to work at the bottom there. If I call it again with a 6, that should also print it's the weekend. So we have these days represented as numbers. And if we were doing something with a calendar, we can use these integers. They get a little harder to follow. What this lacks is any way to really constrain what's passed in. There's nothing stopping me from saying func 10, giving 10 as the day of the week. What should happen then? Like, it's gonna work. It's gonna print go to work. Ideally though, it should be an error, right? And we could crash the program. That's not that hard to do. But what would be better is if we just kind of make it impossible for someone to pass in a number that's not in our range to begin with. And then if someone tries to give us something that doesn't make sense, we just error out. So for that, we create our own type that has values inside of it. So I'm going to create a second file here. I'm going to call it day.java, just day. I'm going to specify just the days of the week. So my type is going to be public enum, not public class, public enum, day. And then in here, separated by commas, I will list out all the days that I want to have available. So I will write Sunday, and then I will write a comma, not a semicolon. So Sunday followed by Monday. And then what after Monday? I have to write a comma, and then a Tuesday, comma, Wednesday, comma, Thursday, comma, Friday, comma, Saturday. That's it. So I could separate this over a couple lines here, but you can probably have this all on one line. Now this is my new thing. These are the values it can hold. So now the possible values for day are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So if I come back in here, I want to change the function to take a day instead of an int. So I change that to day. And then in here, instead of saying 0 or 6, I say if day of week equals day.Sunday or equals day.Saturday, print that it's the weekend, otherwise go to work. And then I can change these down here. So instead of calling it with ints, I'm going to call it with those values. Day.Sunday here. Instead of 2, I want day.Tuesday here. Instead of 6, I want day.Saturday. And then instead of 10, there's nothing instead of 10. 10 was a mistake, but I can't make that mistake anymore. And I get the output I expect. I get it's the weekend for Sunday, I get go to work for Tuesday, and I get it's the weekend for Saturday. So this changed to day, this changed to equals day.Sunday, this changed to equals day.Saturday. I can delete this comment now because this comment doesn't add anything to the code. Like, you can look at it and just see if it's Saturday or Sunday. Pretty obvious that that's what that if statement is checking. When it's 0 or 6, a comment is kind of necessary to explain what those mean. But when it says Sunday or Saturday right there, you don't need the comment. So by convention, you follow the same kind of naming here, where you have a capital for the first letter, and then everything inside of the enum, you capitalize everything. So all of the letters will be capitalized. It doesn't have to be 3 letters like this. I'm just doing this to keep it shorter for days, but you will generally have them as all caps. So you have that. I want you to make another file, call it month.java, and then make a public enum month, because if we're dealing with dates, another thing people mess up a lot is they pass in like a month of 20. One more file called month.java. Sorry, you can use the full names of month. I'm doing kind of a disservice by saying it this way. If you want to write April as the full thing, then go right ahead. That's fine. I was just trying to save you the time of typing. Enums can have any number of characters in their values. And then once we have a month, we can make a date class itself that holds these things as its instance variables. We can have a date class, and our date class can be public day, and we'll call it day of week. We can have a public int day of month, so that'll be the actual date of the month, a public int year, and a public month. And then create objects of this once we have the month. I don't have a month filled in, but that's where we can go eventually once we have a month. You can pass enums around, you can put them inside of other objects. Of course, you can embed your own objects inside of other objects. It's really good for distinguishing things like this, where you might be tempted to have integers where you have like a 0 representing something and you have a 1 representing something else, and like a 2, a 3, a 4. If you just have 2 things, you can usually individually do it with a Boolean where you can just have true and false, like whether something was clicked on, whether the player passed a certain point already, whether they completed a certain quest, whatever. But with this, you get different states, like whether they started the quest, whether they're in the process of it, or whether they finished it. Can anyone think of any other things, especially with games, this comes up a lot. Can anyone give me any other things that might be represented better as an enum than you might be tempted to do them with integers? What about if you're doing some kind of navigation thing with a game, you might have north, south, east, and west represented as an enum, so you can have like a direction. What's one class we've come back to a few times by now in the last like week or two? Done deck of cards quite a bit. Now, is there anywhere in the deck of cards that you think might benefit from using enums? The suits of the cards. Right now we're representing that as a char, which works, but it doesn't stop someone trying to create like the jack of Q's or the 2 of Z's. They can just pass in whatever they want and it'll work. Or the 4 of new lines. They've got possibilities here, and we want to limit that. What I have here at this URL right here is a main, a card, and an unfilled suit. The main.java is trying to build a deck of cards using the suit. There's this really convenient thing that enums give you where you can do the name of it .values. So you can do like day.values parentheses, and it will let you iterate with a for each loop over it. You can get like Sunday, Monday, Tuesday, Wednesday, or in this case, all of the suits. So what I want you guys to do is go to this URL here, make sure your capitalization is right. You don't have to change the main. You're going to modify the card class to use suit instead. So there shouldn't be any more chars in here. It should all be in terms of suits, and you're going to fill in suit.java with the enum that you need. You're going to write the suit enum yourself, and you're going to modify card to use it. So you're going to go there, then you're going to fork it, and then you're going to write your own stuff. And that's your exercise. All right, so my suit.java is simply going to be public enum capital S suit, and then I will have all these things listed out. So I'll have diamonds, comma, hearts, comma, clubs, comma, spades. And now I'll get some other errors because my card class is still set up to use chars. So if I want this to work, I need to change everything in here. So I'm not having a char suit. Suit is my type here as well. My constructor, same thing. It's not going to take a char, it's going to take a suit. And then at the bottom, when I have get suit, this isn't going to return a char anymore. It's going to return a suit. And now I have this really, we could change this so that it prints out a different way by changing what toString does. So now I've got enums. Colors is a really common case for enums. So this lets you constrain things really well. It's very obvious like what a suit is because you can just look at this and see, oh, here's the possible values of it. And then we guard against the errors. We guard against people creating the ace of M's or whatever. The last thing I want to talk about today is something called a switch. If you've gone through Code Academy, then you've probably seen switches already. A switch statement handles cases when you have a big else if ladder and you have a bunch of like I equals 1, else if I equals 2, else if I equals 3, else if I equals 4, whatever. A lot of times you'll have stuff like that with menus. So for example, if I had something like int I equals 2, I could maybe have a big if else ladder that said if I equals 1, then I'm going to print out it's 1, else if I equals 2, it's 2, which is greater than 1, else if I equals 3, I'll change this to say it's 3, which is greater than 1 and 2. If I run this with I equals 2, I'll get that middle case printed out, and then I'll just add another else at the bottom to say else some other number. Got this nice big if else. If it's 1, we print it's 1. If it's 2, we print it's 2, which is greater than 1. If it's 3, we print it's 3, which is greater than 1 and 2. Otherwise, we just print out the string some other number. A switch handles these arguably a little more cleanly. Some people don't ever use them. I kind of shy away from them because they're a little fragile. But the way you would write a switch for the equivalent of this if else, so I'll just comment out the if else here. You start out with the word switch, and then inside of parentheses, you put that value I. So you would say I'm switching on I, the thing I'm like doing different things based on. And then you write the word case and the value you want to check. I equals 1 here. I just copy that thing here, and that's my 1 case. So if I is 1, it will jump to that case 1. Always, 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 always remember to put a break at the end of a case. Always remember, if you leave out the break, it will compile. It's valid code. But if you leave it out, it will confuse you. And we'll talk about what it will confuse you with in a moment. I can also handle case 2, and I can copy both those lines here, and then I put a break down here. Don't forget the break. I'll put a case 3. I'll copy my lines from case 3, and then I stick a break down there. And then for everything else, like my else case, I put in a default. And I'll copy that systems.out.println line from down here. Break. So here's an equivalent switch here. I say switch I, case 1, prints out it's 1, case 2, prints out it's 2, which is greater than 1. So that's the case I'm hitting. Seeing if I is equal to 1, if I is equal to 2, if I is equal to 3. The different cases of what I could be. And then default will be if it's a case I didn't handle. So if I is anything other than 1, 2, or 3, will end up down here. You could put these in a different order. I could put case 2 before case 1 if I wanted, just like I could with an if else. Kind of a convention to do it this way. I is 1, they'll print out it's 1. 3, it'll print out it's 3, which is greater than 1 and 2. 5, I'll get my default, some other number. It can help with clarity a little bit because if I see an if-else ladder, you don't really know that those conditions have anything to do with each other. So like the first one might be if I equals 1, and then you might have else if I is greater than 7, else if name dot equals Ryan. But here I know that everything here just depends on what I is. So I'm handling different values of I. With our ATM, you might handle the menu as a switch where the user enters 1 to withdraw, 2 to deposit, 3 to whatever. Now, what I would like to show you is why I'm yelling so much about this break. If you leave out the break, again, it will compile, but it will do something called a fall through. So if I take out the break now, I have case 2, and I have these 2 things that I expect to print. But what actually happens is all of this gets printed. So a break tells you this is where the case ends. If you don't put the break in, it will continue through to the next case. This is called a fall through. It falls through the bottom of case 2 into case 3. This is widely considered to be a mistake in language design, and it's a big mistake, and it's caused a lot of errors. So make sure you put the break in, otherwise you'll fall through. You generally never want this. Again, this is like an inheritance that came from C++, which is self-guided from C. So some people just will say never use switches because they are kind of fragile, because if you forget the break, then you just shot yourself in the foot. And this is something you can get away with not having. You don't really need switches ever. You can do everything with an if-else, and that's fine. This is just something for your information, and it will come up capital N 5 lowercase xo/0.